ChatGPT. The world is trending on this topic, but what exactly the architecture behind it? What exactly these models are running on? So in this video, we will be covering the architecture behind ChatGPT, that's the Transformers architecture, and we will be also covering how actually these models are deployed on. So let's get started. ChatGPT is a large language model that is deployed on Azure Cloud Service from Microsoft in 7A100 GPU with front end in Next.js. So whenever we are giving a prompt or an input in text format, we are getting an output in text format. And in latest GPT-4, they have added multimodality, where you can also add images, videos, and even documents. So this is the overview of ChatGPT, and next we will be going for the architecture of Transformer. So let's begin by saying there are 6 layers in Transformers. First, the input encoding. Second, position encoding. Third, the main self-attention layer. Fourth, the feed-forward layer. Then fifth, the normalization layer. And the last, output layer. Let's explain these layers by giving an input. Say we are giving an input, the cat sat on. So this sentence has been split to tokens, which is simply speaking these individual words, and we are giving a number, says 0.6, 0.7, 0.8, and maybe 0.4. This number is actually a vector, or in general it's a matrix. So we'll be looking into the vector part. So vector is anything that has both direction and value. So we are giving these words a vector value, or simply speaking a value, so that the machine has to identify. The machine doesn't know it's actually a sentence or not. So it has to be converted to machine readable format. And in encoding layer, the job is to convert these human readable text into machine readable formats, that's vectors. So machine only understands ones and zeros, so which means it has to be converted to a number. So it's converted to numbers. Then positional encoding. In positional encoding, what exactly happening is you have to give the position of each individual word. The cat sat on. Each individual has its own position. The cat has 1. The has 1. Cat has 2. Sat has 3. On has 4. So each position has to be identified so that the next word can be generated. So that job is done in positional encoding. And after that, it went to the positional encoding vectors have been sent to self-attention layer. Say the new vectors are 0.5, 0.6, 0.7, 0.8. Say randomly, just for this example purpose, let's say the positional encoding value with the position is this. Then we given to the self-attention layer, where the self-attention layer will give the weight value to these vectors. So the weight is very simple. The cat sat on has importance on cat and sat. So the important words in the sentence is cat and sat. So let's take another example. Say uh, the Alice went to New York. So Alice went to New York. New York has the value that is Alice has to have higher priority, and along with New York or maybe London. So the Alice went to London or Alice went to New York. The place has to have a priority along with the name. So both word has these priorities. Similarly, the cat sat on. The cat and sat has to have higher priority. So the priority value has been assigned in self-attention layer, then fed to feed forward layer. So in feed forward layer, the layer's job is to identify the features, more features from the sentences. So GPT has trained on a lot of data, say social media data, science journals data, and also Wikipedia data, a lot of conversational data. So these data has to be correlated. It has to have some features has to be extracted. So in feed forward layer, a lot of features will be extracted. So in this example, the cat sat on has to have a lot of features. So the cat is acting on something, right? So it has to extract that features also. So the features have been extracted in feed forward layer. Then normalization. So in normalization layer, when you train this AI model, there are a lot of problems will occur. A lot of even a lot of losses and kind of thing will happen. So it has to be normalized. So the numbers has to be normalized so that the output will be perfect. The accuracy has to be increased, right? So normalization's job is to normalize these values so that the output you get a good result. So after that, the output layer, it will generate a probability distribution. So the cat sat on, when you're giving the input, the cat sat on, the output may be the cat sat on, let's take it here, cat sat on the table, or the cat sat on the bench. So there are a lot of different probabilities of the completion of the sentence. So these probability distribution have been generated on the output layer, and you will get the output in human readable format. So these layers will do the encoding part, and these layers do the decoding part, pardon me on that, and these layers will do the encoding part. So the cat sat on the couch, the table, the desk. That will be done by the output layer. So in generally speaking, transformers have 6 layers: input encoding, position encoding, where you convert the input text to vectors, and in self-attention layer, you're giving values, the weight values that the cat sat on. The cat and sat has to have values, and the output is actually in feed forward and also in uh, normalization and in output layer. The job is to decode it and human readable format, extracting more features and also giving a probability distribution. So this is the overall architecture behind transformers, and and after training these models, the job is to make it as a model file. Say, so the model will be saved as a model.pt file, which is a PyTorch file. And using PyTorch library, we are using an API and deploy it on a Microsoft Azure cloud service. And you just calling this API on the Next.js application using a REST API. So probably it's a REST API and you're calling it from the front end. So this is the overall architecture of transformers and how exactly these models are deployed. So they are using transformers and also maybe using a PyTorch in order to deploy this model. So this is the overall idea of ChatGPT, transformers, and how these models are deployed.